you should fulfill the customer needs. So simply you need to fulfill the customer needs in terms of the performance, in terms of the time to achieve the certain task, and so on. So simply we need a mathematical model in order to control the system. Now the mathematical model can be either differential equation, or simply we will use Laplace in some part of this course, because Laplace transform will, let's say, transfer the linear time invariant system into a set of algebraical equations. And we know that, all of us know, that dealing with algebraical equation is more easy than dealing with the with the time domain or differential equation. This will go in detail in this course, and simply we need to design the controller either in frequency domain or in time domain. Also, this course has a prerequisites, which is the signal and systems, and the code is E260. Now in signal system, what we need Laplace transforms actually. So I will consider that, or I will assume that all of you have the basic knowledge of Laplace transform, and only I will review, let's say in short, the Laplace transformation, and we will use Laplace as a tool in this course. Now, the topics that we will cover, or let's say before that, what we assume that you will achieve after finishing this course. So this actually our outcomes. In the end of this course, we need all the students to understand the meaning or the differences between the open loop and the closed loop control system. So simply, the first thing you should understand what's the meaning of the open loop, what's the meaning of the closed loop, and their physical meaning, how to distinguish between the open loop and the closed loop, when you will choose the open loop over the closed loop, what the advantage of the open loop over the closed loop, and so on. After that, also, we need you to have a knowledge to construct a mathematical model for a physical system, either via transfer function or state variable method, which means that if you have a physical system, if I'm giving you a problem, a physical problem, let's say I'm giving you liquid level control problem. So what you need simply to do a mathematical model for the tank, the pump, the valve. And after that, you need to design a controller for the mathematical model. Then you will implement let's say the controller to the physical system after verifying your controller in the mathematics. Simply why? Because in the mathematics, if you fail to achieve the certain task, or if you fail the stability, which means that the system behave in very aggressive manner or an unbounded response, in this case, you are not losing anything, because simply you are dealing with a set of math or mathematical equation. So that's why we need a mathematical model. Simply why? Because we need to design a controller for the physical system, but in the first stage, I need to design the controller for the mathematical equation. After guarantee that my controller behave as intended in very good manner, after that, I will go to the field, I will go to the lab, I will go to the, let's say, my workshop, whatever you call it, then I will implement my controller in the physical system. So in this case, at least I know that I will protect my system. The result will be somehow close to the theory, but in the end of the day, I need to do some kind of what we call it fine tuning, because there's a mismatch between the physics and the math. Whatever you are very accurate in mathematical modeling, you cannot capture the physics. The physics is very complicated. What we are doing is simply to capture the main features, let's say, of the physical system. Then we need you to understand how to analyze the system behavior and the stability. And the stability is very important, actually, because if the system is unstable, there's nothing you can do. And the stability, if related to human, let's say, product, it's very important. So simply before you are designing your control, in the first stage, you should guarantee the stability. And after that, you should, let's say, discuss the performance. Then we need you to understand the analysis of the design of the system in the frequency domain. We have two domains, actually, the time domain and the frequency domain. And finally, we need you to design a controller in order to get, let's say, satisfactory behavior for the physical system. This course has two student learning outcomes, which is the first one and the second one according to the ABIT. For the course schedule, here we are covering almost 10 chapters of your textbook. The first chapter is Introduction to Control Systems, the basic element of the control system, the difference between the open loop and the closed loop, the meaning of the stability, sensitivity, the sensors, the plan, the process, and so on. After that, mathematical model of the systems, which will be covered in chapter 2. Simply, we will use the law of the physics in order to put a set of equations that describe the physical system. After that, we have the state variable model. It's actually a mathematical modeling in time domain. And this one is attractive now because we have all computer. And simply, if you go to MATLAB and try to model a system, in differential equation, actually, the MATLAB is using state variable methods. Then we'll discuss the feedback control system characteristic. After that, the performance of the feedback control system. Then we'll discuss the stability of the linear control system, how we can judge about the stability, the meaning of the stability. And after that, we'll discuss how to design the controller using a root locus method. Then we'll discuss the frequency response, the stability in the frequency response. After that, the design of the feedback control system. Now, you know that for the exams, we have midterm and we have final. And those exams are supposed to be in the university. So the midterm will count for 30%, the final is 50%. The date for the exams will be according to the university calendar. If not announced, I will announce later. And this will give a room for 20% for homework quizzes or sometime, let's say, performance of the students through the lectures, which means that I will ask questions. And then I will tell you that I will give a point for each question asked in the lecture. And you will get maybe 5 to 10 points if you are following up in the lecture. For the policies, if I'm giving you a homework, you're supposed to submit it within a week from the announcement. And for the attendance policy, please fulfill the university policy. So this is the, let's say, a short description for the syllabus. If you have any question, by the way, here you can raise your hand if you need any question. So I can, let's say, give you the mic and answer your question, of course, if I can. So if you don't have any question, I will go and start with the lecture. Okay. So anytime you can use the raise hand button, and simply for the quizzes, sometime it will be not announced, which means that all the time you should be ready. The 20, let's say, percent can be anytime. Maybe today I will give you a quiz, by the way. So simply this will give you, let's say, a reason in order to attend the class all the time to be ready. Okay, so I will try now to share my desktop. Can you see now the whiteboard?
دكتور شايفين.
Good. Okay. Now I will try to conduct the lectures using whiteboard. I'm still learning, so please be patient. Huh? So what I will use is, let's say, a pen, and I'm having here a writing tablet, and this one's connected through a USB to the computer, and I will try to, let's say, to choose the pen and write here. For example, this is the EE 440, which is the control systems. And this will be lecture number 1, which is the introduction to control systems. Is it okay? Can you read my handwriting?
دكتور
Yes.
تمام.
Yeah.
تمام دكتور.
Okay, good. So at first, you should highlight with me the meaning of the control systems. Anyone of you can help me with that? In the first stage, what's the system?
مدخلات ومخرجات يكون في عمليات بيناتهم.
Okay. So simply you mean that any system has input and output, or any object, or any box, let's say. Yeah? Let's assume that here I'm having a box, and here I'm having an input, and I'm having an output, correct? So this is an input, and this is an output. This one is system. Huh? Of course, this system must do certain task. Huh? It's a physical system. Huh? So simply, who can give me example for any system? Example. Let's say washing machine. I will give the first one. This one is a system or not a system? Yeah?
System.
Yes, system.
Who can give me another example for the systems?
ممكن receiver دكتور.
The receiver is a system. Simply the receiver receive, let's say, analog signal, yeah, converted to a digital signal, something like that. So let's see here, receivers. Oh, who can also give me another?
Filter.
The printer, yeah, the printer is also is a system. So if you notice here, even printers, the washing machine, the receiver, the printers, actually those are not consisting of one element. It's multi-elements. The washing machine has what, for example? The washing machine has drum, has motor, has pump, correct? Has, let's say, case, cover. All of that are linked together in order to perform certain tasks. And the task is what? Is doing laundry, correct? Washing the clothes. Yeah. So Now, what's the control system now? What's the meaning of the control system? So, and the control system actually consists of subsystems, such that the washing machine has a subsystem. Let's say the motor, the pump, the cover, and so on. And the process. The process is what? Is the quantity to be controlled. So here I can write the process. This one, the object to be controlled. This is very important to understand that I need to specify or to determine the process, what I'm controlling. Yeah, the physical quantity to be controlled is what? For example, in the washing machine, what I'm controlling, by the way, what I intend to achieve, certain clearance, correct, of the clothes. I need to wash the clothes in order to achieve certain clearance. Yeah. So simply here, the control system. So here we can write the control system consists of subsystems and a process, which is the object to be controlled by an input. So simply I need an input, which is in general external signal. I'm injecting the input in order to, let's say, fulfill specific performance. Yes. So I will now give you example. And for that, let's assume here I'm having example. And for the example, I will use, let's say, liquid level control. Now, okay, just a minute. So, in the liquid level control, let's assume that I'm having here a tank. And in this tank, I'm pumping water or liquid. So here, let's assume that I'm having a valve. And here is a human that try to control the gating or the opening for the valve such that the flow Qn is enough to level the water or the liquid in certain height, let's say h. Take in consideration, I'm having Q out. So simply here, the human is what is watching the level, sensing. Huh? So here, sensing the level, and according to that, he or she, let's say, adjusts the gate of the valve in order to achieve certain performance. And let's assume this is the desired height. Yeah. So simply, if I'm modeling this system as a box, as a system control system. Now, this is the control system. Huh? The control system has input and output. Now, what's the input to the control system? Simply here, this person here, or this engineer here, he's actually setting certain reference, correct? Which is what? The desired height. Yeah, according to that, he will adjust the gate valve according to the desired height and the actual height. So simply, this here I can write, this is actually the desired output, which is actually the reference signal. Or sometimes we call it command signal. And this is the control system here, which is the liquid level control. So let's assume this is the control system. And the output of the control system is the actual height. So this is the actual output. And in this example, it's what? The liquid level. Yeah. So this is very interesting because in the control system, I know exactly the input and the output. The output is the process that you need to control. So simply here, the process is what, by the way? What I'm controlling here? Who can tell me what I'm controlling in this example? Anyone can tell me that?
Liquid, doctor?
The liquid level. Yeah? The liquid level. Yes? I'm controlling actually what? The liquid level. So simply, we can define here the basic elements of control system. So the first one is the process. And already we defined to what? The physical or the object quantity to be controlled. And here I'm controlling what? I'm controlling the liquid level. Yeah. Now, the liquid by itself can rise or reduce in height by itself.
No.
No. If you're having a Musa stick, yeah, you can rise the water, but simply we don't have it, huh? So by itself, the water cannot change its level. So what I need certain mechanism in order to give the power or to put the process into automatic action. And this actually what we call it the actuator. So actuator is a mechanism to put the process into automatic action. Which means that to provide the power to the process. And here in this example, what's the actuator? Or how I can control the flow rate of the liquid. Because if I control the flow rate of the liquid, I'm controlling the liquid level, correct? Yes or no?
صحيح دكتور.
So simply how I can control that? By the valve gating, by the valve. So here, simply in this example, the actuator is actually what? The valve. Yep. Now, the actuator by itself is the valve. The actuator don't know what to do, opening the gate or closing the gate or maintaining the gate. So simply we need a mechanism in order to tell the actuator what to do, correct? And this will open the door, let's say, to define the controller. So the controller is what? Is a mechanism in order to tell the actuator what to do. So here we can write the mechanism to tell the actuator what to do. So in this example, the actuator is what? Or the controller is what?
Human.
The human, yes, because the human is telling the actuator what to do. The human is opening the gate or closing the gate. So here, let's say the human. Good. Now, this is the process, the actuator and the controller, correct? Now, let's define also the human, how the human will judge that he or she need to open the gate or close the gate or maintain the gate. The controller, how he can do that? He needs information, correct? Yeah.
صحيح دكتور.
And how this engineer here get the information?
ممكن بالنظر أو sensor.
So simply here he is using his eyes, sensing. So simply this means that he's, let's say, using his eyes in order to observe or in order to sense the level. So he need here, for example, we can also have, let's say, number 4 here, and let's say it's a sensor. And this only, not all the control system has sensors, by the way. Only if I will discuss now with you. So the sensor is what? Sensor is a device that measure the process, the physical quantity, and convert it to another form useful for controlling. So simply now, the human eyes convert the actual liquid level into what? Actually, to electrical signal, correct? Because the brain, our brain here, only understand what? Electrical signal. Can the brain understand anything else? All of what we are sensing is converted into what? Into electrical signal through our sense. So if you see, for example, something you never saw before, can you judge what's that? No. Why? Because your brain has no information about it. There's nothing to, it will be mysterious object. So the sensor is a device that measures the process, which is the physical system, and convert it to another form useful for controlling. Now, in general, in electrical engineer, most of the sensors are electrical sensor, which convert the physical system into voltage, let's say, or current, according to the application. And now for the sensors, not all the control system has a sensor. Only later on what we call a feedback control system has a sensor. The open loop control system has no sensor. This is later on we will highlight it. So this sometimes is included in the basic element, sometimes it's not included in the basic element. Now, in the basic element, we have the input and the output for the control system. So here, let's me give a room. So if we continue with the basic elements, let's say number 4, the input for the control system. The input is what? And also we need to discuss the output of the control system. Now, in this example, the input to the control system is what? If you see this, let's say, control system as a box, the input to that box is what? And the output to that box is what? Now it's written here. The input to any control system is what?
Doctor, by the desired height.
The desired height. Yeah.
Oh.
And the actual output is what?
الاوتبوت اللي ننفذ البروسيس مثلا زي نفتح الصمام هذا او لا اتوقع.
No, the actual height. The actual height. So simply the input here for this example, the input is the desired level. So the input here, the input to the control system is the desired liquid level, and the output is the actual liquid level. So specifying the input and the output is very important, and it's very simple, by the way. If I'm controlling, let's say, the temperature in a room. This is not a room, huh? Let's try to fix it. Okay, I think it must be. Okay, let me control my hand. Actually, what I'm doing now is a control, because what I'm trying, I get it. So let's assume that this is the room, and simply here is the air conditioning system. And I need to control the temperature inside the room. So who can specify here the basic element for the control system, which is the process, the actuator, the input and the output, and later on I will include the sensors. So this is the room here. And let's assume now, the initial point, the initial temperature, so the temperature at T equal to 0, let's assume it is 10 Celsius. And I need to control the temperature inside the room in order to all of the in-house resident to be happy. So this is what we call temperature control, correct? Who can tell me the process is what?
Temperature.
Yeah, the room temperature, huh? So here the process is the room temperature. And the actuator is what? The actuator.
Air condition.
The air conditioning system, yeah. So let's assume it is the air conditioning or split unit system. And what's the input to the controller? And what's the output to the controller? The control system, that's it. Now, I think most of us know how to deal with the air conditioning system, correct? You have a remote, yeah? Correct? You have a remote? And in that remote, or in this remote, what you are specifying?
نحدد درجة الحرارة اللي بدنا إياها.
So the desired output, correct? The desired temperature, yes? Yes or no?
Yes.
Simply, when you pressing 20 Celsius or 25, you are telling the air conditioning system that I need to make my room temperature equal to the set point, correct? Yeah?
Yes.
So simply here, the input to the control system so for this example is what? The desired temperature. Yeah? And the output of the control system is what? Is the actual temperature, correct?
Yes.
The output of the control system is the actual temperature. So simply, this is very interesting because if I'm defining error signal, E of t, then what I'm targeting is my y, let's say desired of t minus y of t, yeah, must go to 0 as t go to infinity, such that this one is the desired output, and this one is the actual output, correct? Yes or no? And of course, this one is the error signal. Huh? This is the objective of any control system, correct? So any control system, whatever the control system, the objective is to make the actual output equal to what? The desired output, correct? Yes or no?
صحيح دكتور.
Good.
دكتور بس ممكن توضح المعادلة لأنه
Okay. Now, what I'm saying that now here I'm trying to highlight the objective of the control system. Now, if we recall that when we plot a box here and say that this is the control system and here we have input and output, and for the control system, we stated that here the input is the desired output, and for that I will use yd of t as indication for the desired output, and here the output of the control system is the actual output, and for that I will use mathematically, y of t. Now, if you notice from our discussion, we stated that in the end of the day, I need my actual output equal to what? The desired output. In the air conditioning problem, when I'm setting the temperature to a certain specific, let's say, temperature, 25, 30, 18s, it's according to what? To the user, correct? What I need the room temperature to adjust such that the actual temperature is equal to what? The desired temperature, yes or no?
Yes.
Okay. So mathematically, this is very interesting because if I'm forming an error signal E of t, and I'm defining this one as y d of t minus y of t, so mathematically, the objective of the control system is to make E of t go to 0 as t go to infinity. Yes? Of course, by the way, you know the meaning of the infinity, huh? This not mean that you will wait for the day after in order for the temperature to be, let's say, reaching the desired. No. This means that for certain time, which is mathematically the system settle down, go to infinity, but simply for me, maybe the infinity is 4 minutes. For you, maybe the infinity is 2 minutes. So simply this is, let's say, order of magnitude to indicate that the time is sufficient and large enough in order to reach to the set point. So sometime also we are calling this one set point. Did I clear your question? Yes or no? Did you understand my answer? Yes? Yeah, okay. So let's see. Who specify the desired, the input to the control system? The set point, the reference, call it whatever. Sometimes we call it the command signal. Who specify it? Who specify this one? The human, the user, the end user, huh? The end user. Okay. So simply this is can be changed. Yes. So for you, maybe you are selecting 20 Celsius because this temperature is fit you. Yeah. And you feel comfort if you are living in a room with this temperature. Maybe if I go and ask, for example, let's see now here, Anas Faisal. Anas Faisal.
نعم.
Maybe if I ask you, what's the best temperature for you?
22.
22. Okay. 22. Why? Because maybe he feel more comfort if the temperature is 22. What about Ru'a Abbas? Ru'a?
Yes, doctor.
Yeah. Which temperature is best for you? Okay. All right. Okay. What about Mustafa Ayad? Hey. Mustafa. Yeah, Mustafa. What about BF Gamma 17 مين هذا؟ outside of the organization.
دكتور بشارة قمو دكتور.
شاركت مرة ثانية.
ما شاركت اسمي بشارة قمو.
ليش طيب حاط ايميلك من خارج ما تستخدم جاست مش احسن؟
دخلت من رابط الميتنج لأنه الإي ليرنينج مش فاتح عندي دكتور.
يلا يا بشارة.
نعم دكتور.
يا بشارة. Which temperature is best for you?
27 I guess.
27. So simply, this is only example to highlight that the desired output is depend on the customer, or let's say depend on the actual system. Yeah, it can change. Correct? Yeah. Someone can say that I will put it 100. It's impossible. Correct? Can it? Can you do that?
لا يا دكتور.
Why?
ما أقدرش أتحملها.
Not because of that. The physical system cannot maintain it. Simply, if you go to your air conditioning system, they tell you that this air conditioning can provide you with a temperature from -10 Celsius, for example, until 40. After that, it cannot. Simply, it's like what? It's like you are controlling a car, and in the car, by the way, yeah, let's plot here a car. I like the cars, and let's assume this is a car. So maybe I cancel the design for Audi. Maybe you don't know. Yeah. So this is the wheels. Yeah, this is the wheels much. And let's assume that I need to control the speed of this one. Huh? Speed of the car. Now here the same. Let's highlight the input and the out of the control system. Here, what's the input for the control system for this example?
Desired speed.
The desired speed. Yes, thank you. مين معي؟
محمد خالد.
محمد يا خالد. Okay, thank you, Muhammad. The desired speed. Okay, just a minute. I will take a call and I will return back. Okay, just a minute.
Okay.
Okay, sorry for that. And this is one of the disadvantages for the online. Okay. Muhammad told me that. Hello. جاهز بحالك. So Muhammad told me that the input for this system is the desired speed, correct? So, and the output is what? Is the actual speed. Now, if I'm asking you, Muhammad, how you specify the desired speed or the reference speed? Let's say the reference speed.
دكتور ممكن حسب الشارع، حسب إذا في أزمة، حسب الشارع كم الماكسيموم سبيد تبعيته.
So simply according, let's say if you are a good resident, then you should obey the car sign, correct? Let's say here 8. Yeah, the road sign. Yeah. If you are in rush, you don't care about this one because you have emergency, let's say. So now your objective to reach certain location in certain time, correct?
صحيح.
So simply this means that the desired speed is changing according to what? To the circumstances. But can one say that I will set my desired speed to be 250 kilometer per hour? Now
Yeah.
the car can handle that. I think the maximum of the car is 220, correct? Maybe, I'm not sure. Or let's say here 350. Of course, you don't have Lamborghini, huh? If you have Lamborghini, maybe you can do that. So this means that the desired speed must respect the physics, correct? Must respect what? The physics. Yeah. Now, what about the actuator here? The actuator here is the engine, correct? Here we have the engine. And what about the process? This is the process here is what?
Speed of the car.
The speed of the
دعست
car.
البنزين.
No?
دعست البنزين بقول.
No. Here the process is speed of the car. Of course, you know that the speed of the car. The control system is composed subsystem. So someone will say that I will control the fuel pedal, correct? Because the fuel pedal will control what? The valve that will control what? The fuel injection to where? To the engine, correct? Yes? Yes or no? Yes. Simply, if I make it very simple, if I'm driving a car, I'm watching my speed, then I'm adjusting the fuel pedal according to the speed. Yes? And the fuel pedal will adjust the valve. The valve will adjust what the fuel to the engine, correct? So if you can see that in the end of the day, I'm having a box here. Huh? This box has global input and global output. Now the global input is what? The desired speed. The global output, the actual speed. Inside it, I'm having subsystems, correct? And each subsystem has what? Has input and output. Yep, correct. Now, if I'm discussing in detail the valve gating, in this case, now my problem will be getting the valve control or leveling fuel level control, or let's say fuel injection control. Yep. Yes. But simply in the general task, the desired output and the input to the control system and the output to the control system is the global variable, which means that here in this case, the desired speed is the input and the actual speed is the output. Yep. Good. Now, if I return back to the liquid level, this one. Now, this example here, is it automatic control or manual control?
Manual control.
Why manual control?
لأنه الشخص اللي بيتحكم بال.
Yes. So simply, if I need to make it automatic control, what I should remove the human from the loop. Correct? So simply this means that I need the control. Why? Because simply if I'm having a human here, you know this one is time consuming because maybe maintain the level 12%. So simply this means that you need a human all the time observing and adjusting the level, and this time and by the way. Yeah. So one solution for that is to remove what? The human. Is to remove the human from the loop. This is very simple, and I will finish after that. So how I can remove the human from the loop? Let's return back.
بيحسب الهاي تبع الوتر لحاله هو بيتحكم فيها.
Okay. So simply this means that I need a mechanism in order to measure what? In order to measure the the level, yes? And the most simple one is what? You know the floating ball? You know the floating ball? The floating ball simply will rise or down according to what? To the level, the liquid level. Then let's assume that this one directly controlling the gate valve. This Q in and this is the Q out. Now, if the level reach, let's say, the set point, then I will, let's say, close the valve. If the level reduced, then the ball will be reduced in height and the gate will be open more, correct? And this means that the Q in or the flow for the tank is what is increased. So this one is what? Automatic action, correct? Automatic control. Yes or no?
صحيح دكتور.
Okay. So I will stop here. This is only, let's say, a test for the lecture. Now I need, is the discussion is okay? The style of the lecture is okay with you, like this one?
Yes, Doctor.
So we will continue in the same style, okay?
تمام دكتور.
يعطيك العافية.
Okay.
Okay. So I will discuss the open loop and نعم.
دكتور ممكن
closed
نحول
loop.
على
تفضل.
تطبيق زوم
حول على تطبيق زوم.
لأنه مايكروسوفت تيمز بيعلق كثير.
دكتور فعلا بضل يعطي هولدنج المايكروسوفت تيمز.
اوكي and هاي الشغله مش موجوده، المشكله مش موجوده بالزوم.
اتوقع هاي مشكلة نت مش
كنا
مشكلة.
ناخذ نيوميريكال وعادي ما كانش يعلق.
دكتور
I think
الزوم دكتور الزوم
ها؟
في مشكلة واحدة، مشكلة الوقت بس في الزوم.
40 minutes. Yeah, 40 minutes for the Zoom.
ده كامل الميتنج مرتين.
Okay. Okay. Let me check about that. Okay. So next, we'll highlight with you the open loop and the closed loop, the meaning of the control system, and we will continue with the lecture, inshallah. Simply, I will try to record some videos and post it for you in order to see it before the lecture, and this will give you a space in order to ask, to understand, and to catch up with the discussion. Okay? Okay. يعطيكم العافية.
تمام.